In this video, we will see what is a magnetic dipole moment. So in the first chapter, we have learned about electric dipole moment. What is dipole moment? Two equal and opposite charges, so plus q and minus q kept a distance of, let's say, 2a apart. 2a apart. So what is the electric dipole moment in that case? 2a, that is distance in between these two, into the magnitude of any of the charge. So 2aq was the dipole moment and it has got some direction. That is from negative to positive. We also have learned an equation for finding electric field due to a dipole at a distance of r. So I am going to keep x away from the center of the dipole. What is the equation? 1 by 4 pi epsilon 0 2p divided by x cube. This we have learned in the first chapter. Now, in the previous chapter, moving charges and magnetic field, we have learned that a current carrying conductor is a dipole. How will it be dipole? See, when the current is passing through a circular loop, at one side when I am seeing, so now this side, let's say here current is going in clockwise direction. So when it is going in clockwise direction, this is south pole with respect to me. Okay. With respect to a person on the other side, for him, this current seems to be flowing in counterclockwise direction. So for him, it is negative. So for me, see, for me, it is going in clockwise direction. So this seems to be south pole, and for you, it is north pole. So there are two poles here. So we can consider it as dipole. Okay. Now what is the equation for magnetic field due to a current carrying coil at a distance x away from it? We have learned this equation, but we were having x square plus a square the whole power 3 by 2 here in the denominator. So actually in the denominator it was x square plus a square the whole power 3 by 2. You can go and check the equation. Everything is same in the denominator. This was the value, but we are considering a is very less as compared to x. So we are ignoring a as 0. So x square the whole power 3 by 2 is x cube itself. Now this is the equation to get the magnetic field due to a current carrying coil at a distance x away from the center of the current carrying coil. Okay. Now, so we have got to know that this behaves like a dipole. It has got two poles, north and south pole. So this is behaving in the similar way. Now we can compare these two equations. Okay. Now when we are comparing, we have a constant here, 1 by 4 pi epsilon 0. We have a similar constant here. We have an x cube here. We have an x cube here. Now we have a 2 here. We have a 2 here. So constant, similar constant, x cube, similar, 2 the same. I could say that NIA is an analogy of P in magnetic field. These are not equal. These are analogous I can say. 1 by 4 pi epsilon 0 is constant. In electric field, the analogy for magnetic field is mu 0 by 4 pi epsilon 0. Mu 0 by 4 pi. So wherever I see 1 by 4 pi epsilon 0 in electric field, to get the same equation for magnetic field, I can substitute it with mu 0 by 4 pi. Where x cube is the same. Now I can say that P is analogous or NIA is analogous to P. So if P can be named as electric dipole moment, I can name NIA as magnetic dipole moment. That can be represented as M is equal to NIA. Now here the reason for magnetic field is the dipole moment, NIA. Here the reason for electric field is the dipole moment, electric dipole moment. Okay, so this is magnetic moment and this is electric dipole moment. You can call this as magnetic moment. Don't use the word magnetic dipole moment by mistake. I have used it several times. So it is magnetic moment here. It is electric dipole moment. Okay, electric dipole moment and magnetic moment. So P, electric dipole moment and magnetic moment here. So we have one more equation for electric dipole moment, that is distance in between the two poles and the charge of one pole. this 2a is the distance in between and 2 is the charge. So we should also have an equation like this here, right? Now we are going to bring a constant that a magnet will be in this way, having north and south pole in this way. Okay. Now there will be a distance in between north and south pole that can be taken as L. And we are going to bring a new concept called as dipole strength. It's not dipole strength, magnetic pole strength, M, small m. So this is equal and opposite. One is north and other one is south, right? So M and M kept a distance of L apart. So similarly, here distance into Q. So here I am going to give the same equation. So instead of L, I am going to keep it as 2L, where L is measured from the center of the magnet to any of the pole. It's the same thing. Initially L I have defined in this way. Now I am going to keep 2L. Why? Then it will become analogous. 2A and 2L here. So what will be the dipole moment here? As per this, when you are comparing with the equation, distance into the pole strength here. I mean here in this case it is strength of the charge. So here it will be M into, this is the pole strength into 2L is equal to magnetic moment, that is M. So these equations are not nowadays used. Pole strength is not that important, but get an idea about what is pole strength. But this one is very important. Magnetic moment is equal to NIA. At the same time, electric dipole moment is equal to 2A. Okay, thank you.